Here there are two identical long wires wound to form circular loops of same radius as shown below. Find the ratio of magnetic field at the center of A to B. The questions involved uh, magnetic field. It's always important to deal with directions as well as magnitude. So, magnetic field at the center of this system will have two contributions. One due to a circular loop, one due to a straight long wire. Total magnetic field. Whether these fields are to be added or subtracted depends on the directions of the field of the circular coil and the straight wire. So you need to know how to find the direction of magnetic field due to circular coil and straight wire along with magnitude. For a straight wire, if it's horizontal or vertical doesn't matter, long wire at a distance r, the magnetic field is given as B equal to mu0 I by 2 pi r, where I is the current flowing through the conductor, r is the perpendicular distance from the conductor to the point where you find the magnetic field. Now for direction, the current is going towards forward straight. You can use right hand thumb rule. Keep your right hand thumb along the direction of the current and see the fingers. If you open the right hand towards the right hand thumb towards the right side and keep the fingers open. If it's below, the fingers will be pointing into the screen. That means magnetic field is cross into the screen, minus k cap. If the fingers you bend upward, the magnet will be out of the screen, below plus k cap. So that's the way you find the direction of magnetic field. Now, for a circular coil, value of the magnetic field at its center, B equal to mu0 I by 2r, where r is radius. And here, the direction will be as per the current. If the current is anti-clockwise, we can use the right hand rule again. Keep your right hand side fingers along the current, or learn it directly. Anti-clockwise current will be always producing field out of the paper, and clockwise current will be always producing into the paper. So here it's anti-clockwise, the field is outside the paper plus k cap. Instead, if the current is clockwise, the field will be into the paper, which will be minus k cap. So here, at this particular point, the magnetic field is due to the straight wire. The straight wire is carrying current to the right side. Using right hand thumb rule, the magnetic field is out of the screen, k cap. Now this conductor circle is carrying current in clockwise direction. Clockwise direction, the magnetic field is into the screen. So the net magnetic field will be greater field minus less field. So if we check here, mu0 I by 2 pi r, mu0 I by 2r. So this is just pi extra in the denominator. So since the denominator is small, the field due to straight wire will be less. The net field, magnetic field, at the center of A will be greater field that of the circular coil, which is mu0 I by 2r, which is into the paper minus k cap. Then plus magnetic field due to straight wire is mu0 I by 2 pi r, which is k cap. So the net field you can find as mu0 I by 2r is common. Then k cap common. This will be minus 1 plus 1 by pi. So if you find this value, it becomes mu 0 I by 2r minus pi plus 1, or 1 minus pi plus 1 by pi along k cap. So we'll get it as finally magnetic field at the center of A equal to mu 0 I by 2 pi r into 1 minus pi along k cap. Here, the straight wire, no difference. The field is still out of the paper. But for the circular loop, it is anti-clockwise. Since anti-clockwise, the field will be K. The only difference will be both fields are in same direction. So this minus will become plus. So magnetic field at the center of system B equal to mu 0 I by 2 pi r, both positive. So 1 plus pi along K cap. So if you take the ratio of magnetic field of A to magnetic field of B, that will be mu 0 I by 2r pi get cancelled. 1 minus pi by 1 plus pi. This value is coming negative. The negative is indicating the direction of the field. So if the direction is not counted, the ratio can be simply B of A by B of B equal to pi minus 1 by pi plus 1. Normally ratios, we don't count the negative sign. So the final ratio will be pi minus 1 by pi plus 1.